In today's repetition course, we will have a look at an electrocyclization to a five-membered ring. So we are used to the formation of four-membered rings via electrocyclization, also six-membered rings. Here an example: if we have a hexatriene like this and heat it up, a six-membered ring will be formed. And according to Woodward-Hoffmann rules, it will be a disrotatoric ring closure. We have to keep in mind 4n plus 2. Thermal cyclization will be disrotatoric. What does this mean? Well, the movement of these substituents are disrotatoric. That means one is moving counterclockwise, the other one is moving clockwise, and they will end up on the same side of the ring. So, like this. A cyclization, an electrocyclization, is also possible with a pentadienyl cation, forming that allylic cation here, and in this case not 6 but 4 pi electrons are involved, and therefore there is that rule 5n means thermal, in the thermal case conrotatoric, and therefore the two substituents will end up on opposite sides of the five-membered rings. Such a cyclization is called a Nazarov cyclization. Let's have a look at a distinct example. So this one, we have a ketone that is double alpha beta unsaturated, and if we treat that with iron chloride, then this Lewis acid will coordinate to the free electron pairs of that oxygen, inducing a cationic charge at this position, stabilized as double allylic, and then a cyclization according to this scheme will take place, leading us to such a structure. Now we can think about, are those electrons here moving clockwise or counterclockwise? So in one case we have this result, in the other case we have that result, but let us have again a closer look. Well, it is an allylic cation. That means these two structures are mesomeric structures. So we can put in a mesomeric arrow and put those two structures into brackets. So I have drawn what should come out as a stereo isomer, of course racemic. Those two hydrogens should be on opposite side of the rings. However, as we lose the stereogenic center at this position, it doesn't matter for the outcome of the reaction. So the iron chloride coordinate to that oxygen can then lose a chloride and ion, and this chloride and ion will attack the TMS group, and TMSCl, trimethylsilyl chloride, will be eliminated, and the electron density will move to this bond, forming a double bond here. Well, and the result then is this cyclopentadiene moiety. Hydrolyzation, under acidic conditions, well, we already have acidic conditions. TMSCl with water will produce HCl, and then it will be protonated here at this position with the hydrogen, the proton, added to the same site where that hydrogen is already located. We get the cis isomer of this product, and since we had no chiral information put into that reaction, there will be a racemic outcome, and therefore we should add the term racemic here. Thanks for listening.